Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how you find the molar mass of an unknown metal in a certain reaction. Okay, so let's get into this. So in this problem you have a 1.00 sample of metal X. You know that this metal X forms a 2 plus ions. That should let you know that this is probably going to be a main group metal in group number 2, because we know the group 2 main group metals tend to form a 2 plus charge. So we're probably looking for, or should expect, this metal to be in group 2. Okay, so this metal was added to 0.100 liters of a 0.500 molar H2SO4 sulfuric acid solution. So you're reacting this metal, and you have an excess amount of the sulfuric acid because after the metal has completely reacted, the remaining acid is requires a certain amount of NaOH. So you have 0.0334 liters of your 0.500 molar NaOH in order to neutralize that leftover acid. So given this information, they want us to calculate the molar mass of our metal. Now, so we wanted to find the molar mass. The molar mass is defined as the number of grams per 1 mole of the substance. So it's grams per mole. So what we need to do is find the grams, the mass that of the original sample, the mass of our X value. So we have that here. So we've got the grams, we've got the mass. So the only thing we need to find is the moles of the metal X that reacted. And so let's start to do this. Okay, so they tell us that we needed 0.0334 liters of our 0.500 molar NaOH solution to neutralize the acid. So that means that the acid that was left over wasn't used in the reaction. So if we use, so we could calculate the number of moles using the liters they gave us and the molarity of the sulfuric acid. That would give us the total moles in the original amount of acid we added. But again, not all of that acid reacted. So we need to find the amount that actually reacted. So we need to find the moles of H2SO4 that reacted. So we need to subtract out the amount that didn't react. So we need to figure out how many moles did not react. And so that's where the base comes in. So the reaction of the base with the acid, if we write that formula, so if we write it here, H2SO4 plus NaOH, and that's going to give us two products. And so this is a double displacement reaction. So the way you figure out the products is you take the ions on the outside, you put those together. You take the ions in the inside, you put those together. So H2 and OH is going to give us water. So H2O. And the sodium and the sulfate is going to come together to form another product. And so the sulfate ion has a 2 minus charge. Na has a +1 charge, so we need two NAs for this formula. Na2SO4. So Na2SO4 is the other product. And so now we need to balance the equation. So I have 1 sodium, 2 sodium, so I need a 2 coefficient there. So 2 and 2. Let's see, I have sulfur. Sulfur's next. So 1 sulfur, 1 sulfur, that's balanced. I have 2 hydrogens here, 1 hydrogen here, but 2. So 2 times 1 is 2, so I have 4 hydrogens on this side. I have 2 hydrogens here, so I need to put a 2 there. So now my hydrogens are balanced. And now for the oxygen. So I have 4 oxygens here. I have 2, so that's 6 on this side. I have 2 times 1 is 2, and I have 4, so that's 6. So my oxygens are balanced. So now I have my balanced equation. So, this is the number of liters I have, and this is the amount of molarity. So when I'm trying to figure out the number of moles of uh, NaOH, I can use my molarity as a conversion factor. That's moles per liter, and this is my liters. So I take 0.0334 liters of my NaOH, put that over 1, and then I'm going to use this molarity as a conversion factor. So since molarity is moles over liters, this is 0.500 moles per 1 liter. So, so I have liters on top. I'm going to put 1 liter on the bottom of NaOH. And I'm going to have the moles 0.500 moles of NaOH. Right? So now liters cancel out, but I don't want moles of NaOH, I want moles of H2SO4. So now I can use the mole ratio between NaOH and H2SO4 to convert from the moles of NaOH to moles of H2SO4. So I'm going to use that. So I have moles of NaOH on top, so I want 2 moles of NaOH on the bottom and 1 mole of the H2SO4 on top. So 1 mole of H2SO4. So now moles of NaOH cancel out. Now I can calculate the moles of H2SO4 that did not react with my metal X. This is what reacted with the NaOH. So this is the excess H2SO4. So I can find that and then subtract that out from the number of moles I started with in my original solution of H2SO4. So if I calculate this out, I get 0.00835. So I get 0.00835. Was that 35? 35 moles. 35 moles of H2SO4. So that's the amount that was unreacted. So let's calculate now the total amount that I threw into the reaction vessel. So I had 0.100 liters and 0.500 molar HCl. Before we move on, we should make sure we have the right number of sig figs. So here I have 3 sig figs. The zeros in front are not significant. They're never significant. Here I have 3 sig figs. The 0 in front is never significant. These 2 zeros are significant because I have a decimal point. So that's 3. And this is exact. So my answer should have 3 sig figs, which is what I have here. So I'm good. Here, I'm going to use, again, my molarity as a conversion factor. So here I have 0.1 liters, so 0.100 liters of my original H2SO4. The molarity is 0.5, so that's 0.500 moles per liter. So that means I have 1 liter of H2SO4 on the bottom, and I'm going to have 0.500 moles on top. So 0. Keep making that mistake. Okay, 0.500 moles of H2SO4. So liters cancels out. Now I have moles of H2SO4. Now I can calculate the original amount of moles that was in my solution when I threw it in there. So I calculate that out and I get 0.005. So this 0.005, let me double check. 0.05, my bad. 0.0 0.05 moles of H2SO4. Okay, so this is the amount of moles that I had in my solution when I reacted it with the metal. This is the excess that did not react. So I want to know how much actually reacted. So I'm going to have to subtract this from this. But again, we need to make sure we have the right number of sig figs. Here we have 3 significant figures. The zeros at the end are significant because of the decimal point. This 0 is not significant. It's at the front of the number. So those are never significant. And the same for this. So 3 sig figs, 3 sig figs. So I should have 3 sig figs here. So I need to add a 0 and another 0. So I need to add 2 zeros to this. So it should be 0.0500 for my 3 sig figs. Okay. So now I'm going to take my 0.0500 moles of H2SO4 that I started with and subtract out the unreacted, so 0.00835 moles of unreacted H2SO4. And so then I get the reacted amount, which is going to be 0.04165. So 0.04165 moles of H2SO4. So this is the moles of H2SO4 that actually reacted. And so now that I have that, I can find the moles of my X that reacted with that. So I go back to my equation here. So how do I know how much reacted? So here I know that this forms 2 plus ions, right? So I need a reaction where I can get a mole to mole relationship. So with that, since I know I have X, right? So I'm going to take my X metal, solid X, plus H2SO4, and this is going to be a single placement reaction. So the X is going to react, so it's going to push out the hydrogen, and so I will get hydrogen gas forming from this. And it's good to know that we have an X2 plus ion, because then when that forms, the X2 plus will match up with the sulfate. And since the sulfate ion has a 2 minus charge on it, that will balance with the 2 plus charge. So I'll get an X and SO4. So that's one product. And then, of course, I get H2 gas forming from that. So here's my reaction. So if I balance this out, so I have 1x, 1x, I have SO4 here, one SO4, so that's balanced so far. I have two hydrogens and two hydrogens, so it's balanced. So my ratio of X to H2SO4 is a 1-to-1. So the number of moles that I have reacted of my sulfuric acid is going to be equal to the number of moles I have of my metal. So it turns out that the number of moles of my H2SO4 is equal to the moles of my metal that I had. So since this is the amount of H2SO4 that reacted, that's the amount of metal that I started with. Now I have the moles of the metal. I have the mass of the metal. The molar mass of the metal is grams per mole. So I'm going to take the grams divided by the moles. So I have 1.00 grams of my metal X divided by the moles, 0.04165 moles of X. So we need to make sure we have the right number of sig figs. So here we're subtracting. So because we're subtracting, the rule is the answers should have the same number of decimal places as the least number that we are subtracting. So the last digit is here. The last digit is here. How many decimal places do we have here? 1, 2, 3, 4. So that's 4. How many decimal places do we have here? 1, 2, 3, 4, 5. So the least number is 4. So we're limited to 4 decimal places. So 1, 2, 3, 4. So that 6 is our last significant figure. So here we go here. So this has 3 sig figs. This has 3 sig figs. The zeros don't count. So our answer should have 3 sig figs. So when we divide this, we get 24.0096 grams per mole. But since we're only allowed 3 sig figs, we can only have 1, 2, 3. So the answer is 24.0 grams per mole. So that is the molar mass of our metal. And if we look up the molar mass, it didn't ask us to identify it, but we could identify it. It's probably a group 2 metal, as we said, because it forms a 2+ ion. So if we look here, it looks like magnesium is the closest one. So that's a 24.305. So it could be magnesium. It seems that that's the best choice. So I hope you enjoyed this video. I hope you got a lot out from it, and I hope this helped you. If you like this video, make sure you hit the like button. Please put a comment in the comment section. Let me know what you think if you have any other questions. And please subscribe to my channel. Thank you for joining me. Have a great day.